Hello everyone, we're going to take some notes on types of reactions for organic chemistry. These notes look a little different than what we're used to because I'm on my home computer, not my Chromebook, but you can follow right along with our note packet and fill these in. These are on the last 2 pages of our notes. Just a little fair warning here. In your notes where it says general formula, that's going to be the definition that you copy from the slideshow. I will also, along with the link to the Edpuzzle, I will post this slideshow as well for you to go back and reference. So jumping right into things, the first one we have is substitution. This definition is the replacement of one or more of the hydrogens in a saturated hydrocarbon with another atom or functional group. So saturated hydrocarbons, remember those are hydrocarbons with single bonds here. So over here on our example, you can draw this example. Draw this example. We have C2H6 plus 2 chlorines or chlorine gas, making C2H5Cl plus HCl. So we notice one of our hydrogens came off, and now we have 5 of them, and a chlorine jumped right in. And then what happened was we have to abide by our law of conservation of mass. That hydrogen that came off then bonded to our extra chlorine. So we have 2 chlorines on the left and 2 chlorines on the right. We have 6 hydrogens on the left, 6 hydrogens on the right, 2 carbons, 2 carbons. So all that happened was one of these chlorines, our chlorine gas, broke apart, and one jumped in and replaced one of our hydrogens in our saturated hydrocarbon. So that's substitution. Addition is when we are adding one or more atoms at a double or a triple bond. The added atoms break up the double or triple bond to insert themselves into the compound. So these would be unsaturated hydrocarbons, and I talked to you about this. We are going to do it with smaller carbon hydrocarbons, as you can see over here, C2H4. Organic chemistry, we go into the upper levels, they're a little bit bigger structures here. Addition reactions, though, will always have one product. So substitution we saw had 2. So here we have C2H4, we have an unsaturated hydrocarbon plus chlorine gas. And now what's happening, and I will show you this in class on Thursday in a picture form. What's happening is there's a double bond going on between our carbon and our hydrogens. Double bond. And that chlorine breaks up the double bond and attaches itself. So it makes it now a saturated compound. Then we have fermentation. This converts a carbohydrate or a starch or sugar into an alcohol or acid and carbon dioxide. So over on the right, we have C6H12O6. And then what's happening now is we're making an alcohol and carbon dioxide. So that breaks up and forms that. And this kind of can just happen over time. So that's fermentation. So we have any sort of starch or sugar. And that would be any sort of carbon group with hydrogen and oxygen in some shape or form. We know it's fermentation though when we're making an alcohol, so with an OH group and carbon dioxide. Esterification, this is a reaction between an organic acid and an alcohol to produce an ester and water. So here we have an example with ethanoic acid. We know it's ethanoic because we have 2 carbons and we have that what's the word I'm looking for? Organic acid functional group. And then over here we have propanol. We know it's propanol because we have 1, 2, 3 carbons and we have the OH group coming off. The hydrogen on our alcohol and the OH group on our acid combine to make the water, as we can see in the picture. And then what happens is the rest of the compound add together to make an ester. And we see it's an ester because it has the double bond to oxygen and a single bond to oxygen with other carbon groups coming off. This one is propyl ethanoate because we have the 2 carbons here leading up to our double bonded oxygen. And then after that single bonded oxygen, we have the 3 carbons. So that's where we get the propyl from. So this builds all on the functional groups we talked about yesterday. Next one we have saponification, so how we make soap. This is a reaction when an ester reacts with an inorganic base to produce an alcohol and a soap. Inorganic base meaning some sort of a metal with OH. So in this case, we have NaOH. That's our inorganic base. Here we know this is an ester because of that double bond to oxygen, single bond to oxygen there. This is a much bigger ester, but again, we can recognize it's an ester because of that little functional group going on. we add that inorganic base and we make an alcohol. We know this is an alcohol. It's a much bigger one, but we know it's an alcohol because of those OH groups. And then this is a form of soap over here. This type of reaction we do need to be able to recognize. We don't necessarily need to be able to name those compounds. Those are a little bit above what we do here, but we need to be able to recognize that this is an ester. This is the inorganic base here, and we actually are going to move on to acids and bases after we have our quiz on Thursday. This is an alcohol because of the OH group, and then this is a form of soap. Then we have combustion, which we actually did talk about in our inorganic reactions, but it actually is a type of organic reaction because we have hydrocarbons plus oxygen making carbon dioxide and water. So this is any sort of an organic compound being combined with oxygen to make that carbon dioxide and water. And we did see those in our inorganic reaction unit. But again, this is actually an organic reaction because of the hydrocarbons typically involved. Then we have polymerization, and this is what I've been kind of talking about, things with polymers like slime or our oobleck or the nylon that we saw in that video being made in the small beaker. This is where smaller compounds or molecules are chemically combined to make longer chains of molecules. So we see here we have 1, 2, 3 ethene compounds being added together to make a big long chain of carbons with 1, 2, 3, 4, 5, 6 carbons there. So that would be going from 3 ethenes to one long compound of hexane. So we can have unsaturated hydrocarbons. We can have even, they don't have to be a hydrocarbon. This is just one example, making a longer chain of our carbons there. So that's polymerization. Again, I will post this slideshow back on Classroom in case you missed any of that. Feel free to go back in the video and pause if you need to. Now what I will ask you to do is go over to Classroom and work on identifying types of reactions, the worksheet I've posted for you, and get that turned in to me by the end of class today. And then when you finish that, if you are all done with that, go back and make sure you finish the functional group worksheet from yesterday, where we added to our slideshows. And I will see you all on Thursday. We will go over these. I'll draw some pictures and diagrams for you when I have my Chromebook.